Hello friends, I am your chemistry coach. Last time in my lecture number 1, I told you what are units, what are measurements. In today's lecture, the objectives of today's lecture is that what is a measurement? Can I determine any physical quantity with 100% accuracy, or my measurements which I do in chemistry, in physics or in science, are they 100% correct, or there is some uncertainty in these measurements? And if there is uncertainty in these measurements, what we will do? How will we handle uncertainties in the measurements? We will also discuss in this lecture about precision, accuracy, and also significant figures, and try to solve some of the questions on that. Let us first see that as you go in a chemistry lab, what type of measurements you are doing. Measurement means that you are measuring some physical quantity, and as you go in a chemistry lab, you must have seen that volume is being measured. You are measuring volume in chemistry lab. How are you measuring volume in chemistry lab? You know that you are using graduated cylinders in chemistry lab. Graduated cylinder can be like this. It is marked from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then this is my 10. So starting from 0, I am going to 10 milliliters. Like this, it can continue. You are also using in chemistry lab, what I say, there is a pipette. You are also using a pipette. Supposing this is marked 10 milliliters. You are also doing measurements in chemistry lab, or I am using sometimes substances like beakers. It's written 10, 20, 30. So if you have a solution, you are making measurements of the volume of the solution. If in chemistry lab, you are also measuring mass of the substances. For example, you are also measuring mass or weight. If I consider that you have to prepare a solution of oxalic acid, which is COOH twice, 2H2O, supposing you want to prepare N by 10 solution of oxalic acid, 250 milliliter, then this will involve two types of measurements. First of all, you will have to calculate how many grams of oxalic acid you are going to weigh. You know that 126 is the molecular mass of oxalic acid. 126 by 3 is 53. Sure, you want to prepare N by 10 and you want to prepare 250 milliliter. So this will be about 3.15 grams only. So here you are involved in calculating and weighing oxalic acid 3.15 grams. How will you weigh in the chemistry lab? You have analytic balances and you know that you have a box of weights. By using these weights, you will make a measurement. These measurements are very common in chemistry, and you could also be asked to measure supposing length of some rod or something. Supposing you are measuring a length, how will you measure the length? You have seen that there is a scale which is called a centimeter scale. Centimeter scale. So what you find here is starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is 1 centimeter, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2 centimeter, and so on. This scale has got 10 divisions. So each division is representing 1/10 of a centimeter, which I am talking as a millimeter. Or you could have another scale. In this scale, I am having 0, 10, 20, 30 type of numbers. So these are my centimeters. You can see the difference between the two scales. This is measuring from 0 to 10, 10 to 20, and I don't have marking from 0 to 10 means there are marks inside which have not been shown in this scale. So if you compare this scale with this scale, or if I compare this with this, you will find that the measurements will be better with the graduated cylinder, which has got smaller digits present in it, as compared to this is not going to give me a good measurement, because here the values are going from 0 to 10, 10 to 20, 20 to 30. So if anything is between this, it is more than 20 and less than 30. So what number I report? Supposing I report that this volume is 24 milliliter, then you can say that there is an uncertainty involved in the measurement of this, and the uncertainty always lies in the last digit. All I am trying to show you that we are doing measurements, but these measurements cannot be 100% accurate. There will always be uncertain numbers involved in our measurements. Even I can consider the free fall of this chalk from here, and I want to note down what is the time required for the free fall. It is not possible to record the exact value, the true value. So true value is something which we do not know also. We cannot record the true value of any measurement. This is very clear. For example, here is my pipette of 10 milliliter, and supposing I want to take a liquid of 10 milliliter in this pipette and transfer it to some other beaker. Will it be possible with 100% accuracy? The answer is no, because there is a marking on this. Here it ends 10 milliliter. So if I take a liquid 10 milliliter in this pipette and transfer it to some other beaker, it will not be possible with 100% accuracy. Or in other words, it will not be possible to exactly transfer 10 milliliter of volume of water from this to another beaker, because there will be uncertainties, there will be difficulties. What type of problem can be there? What I am trying to say that we are doing measurements. Measurement of mass, measurement of length, measurement of volume in chemistry lab, but we are not going to get 100% accuracy of our measurements. Therefore, this is very clear whether it is any physical quantity. Even if I am trying to measure the velocity of light, which you are saying is around 3 into 10 power 8 meter per second, the measurement itself is so difficult that it is not possible to get the exact value of any physical quantity or any physical measurement. One. Second, we ourselves do not know the exact value of the true value of the measurement. Therefore, there are uncertainties in our measurements. But I am saying uncertainties are there in every measurement which we are doing. So how will we solve, how will we handle the problem of uncertainty? All I said, there is uncertainty. I measure a mass 5.5 kilogram. This digit is uncertain. You measured a volume by a burette or something, it comes to be 2.53 milliliters. There is an uncertainty in this digit. You are measuring a length which is coming to be 2.74 centimeter, and I am saying this digit is uncertain. Or in other words, all I am trying to say that any measurement which you are doing, in practice, the last digit is always uncertain. We do not know whether it is 2.74 or 2.75 or 2.76. So there is an uncertainty involved in everything. Here the uncertainty is in terms of plus minus 0.1. Here the uncertainty is 0.01 plus minus. Here the uncertainty is -0.1. So these are the uncertainties which we are saying the last digit is uncertain, is not known to us. Therefore, how will we handle these situations? In order to this, we are saying there are errors in our measurements. Any measurement you are doing, there is an error. How much error is there? Now, because there is an error, there is an uncertainty, we do not take one measurement in chemistry or in physics. We do multiple. What we do is multiple measurements. Multiple measurements. That means I repeat my experiment many times. Instead of one reading, I will say I will repeat the experiment 2 times, 3 times, 4 times, 5 times. So after I am doing the measurement many times, I am not getting one value, I am getting a large value. So I assume that if I am doing multiple type of measurements, some values may be higher than the true values, some values may be lower than the true values, but I myself do not know what is the true value. So what we are having, what we are trying to show, that if this is my, supposing this is my correct measurement, I take some values, these are coming at this point, someone else takes the values and he gets these two values, this value is of plus, this value is of minus, all these possibilities are there. So, or there could be measurements which will give this type of values. So, this is a type of systematic error, this is all a systematic error, this is of positive, this is of negative, then this type of error which is here, looks to be a random type of error. Certain errors could be there. For example, when I am talking of a pipette and measuring the volume, because the temperature could be affecting my measurement, because volume of a liquid or density of a liquid is temperature dependent. If I will change the temperature, the measurement value will change, or because I cannot read the exact meniscus of the liquid, even while I am taking the measurement or some other student is taking the measurement, there can be discrepancies. Therefore, what is a practice that in chemistry or in physics we are using average values. Average values, because there is a range of uncertainty in our measurements. My measurements have got a range, and from the true, this is my true value, there is a range of this. Therefore, sometimes what we are doing, we are taking average of the 10 values which we are recording. So we say, okay, plus minus values cancel out, and there is a value. But it is not true, because these errors can multiply when we do more scientific calculations with them. But this problem is there, that my measurement cannot be 100% correct. Therefore, I have to find some possible ways in chemistry to represent the number. Or in other words, I am representing my measurement by some number. Any number, supposing I say this is my number of my measurement of any quantity, whether it's a length, it is a mass or anything. Supposing this is a gram, which is my mass, which I have measured. I am saying that this number is uncertain. The last number is uncertain. And in order to handle such type of situations, we talk of what we call as accuracy and precision. That means I want that my measurement cannot be 100% accurate, but it should be as good as possible. That means it should be accurate as well as precise. So if a student is taking a measurement and his numbers are very bad, I say it's a bad measurement, but I am interested in a good measurement. I am interested in a measurement which is accurate as well as precise. What do you mean by accurate and precise? Let us see. What do you mean by accuracy and precision of a measurement? What is accuracy of a measurement? I am saying there is a true value, and the value which you are getting, estimated or measured value. These two values are not same. If the value, estimated value, is very close to the true value, I say that the measurement is accurate measurement. Supposing the exact value was 1.54, and if I get 1.53, this number is very close to the true value. This is my true value. This is my calculated or measured value. These numbers are quite close. Therefore, I say yes, this measurement is accurate. And precision means, I said I do repeated measurements because of uncertainties, and then we try to take the average of that in order to minimize my errors or uncertainties. Therefore, if I do or repeat my measurement 10 times, how close, how much reproducible my measurements are. That will decide the precision. Supposing the exact true value was 1.54 and I got values 1.52, 1.53 and 1.50, 1.49. As you can see that 4 values have been taken and the true value is 1.54. Therefore, we can say that these values are precise. These values are precise. They are very close to each other. These values are not off. But if a value is coming 1.65, this is very much off. This is not precise because I took 5 values, 1.5, 3, 1, and one of the values 1.65. This value is not reproducible. This is not close to these values. This is not a precise measurement. And our purpose in experiment is to get accurate as well as precise measurements. Or let us see this accuracy and measurement in another way. I am saying that I am a cricket coach and I have to select a bowler for the international match, one-day international match. So I make a scientific measurement. I want to study the accuracy and precision of bowling of the different players. So what I say, okay, that these are my targets. This is my wicket. And I asked that there are 4 persons. I said, okay, you will bowl each hour. Each one will bowl 1 hour. 1 hour has got 6 balls. First player bowls, and I make a CCTV footage camera, and I take the picture of that. One of the bowler, I find these balls are going like this. 6 balls. Now you can see that this is my target. These balls are very far away from each other. Also, they are not close to each other. So I am saying that this is not accurate and this is not precise. The bowler is neither accurate nor precise. Then I find the next man. What I find that 1, 2, 3, 4, 5, 6. What I find that he hits like this. Now these all the balls are falling very close to each other. This bowler is reproducible. This bowler is precise. He is precise, but still not accurate. Not accurate. Because the target is this, he is away from the target. Now I take the third bowler. And what I find that 1, 2, 3, 4, 5, 6. So what I find now, what he has done, he is on the target as well as the measurements are very close to each other. The balls are very close to each other. When I say yes, he is accurate as well as precise. That means this is the person I am going to choose in my next international match. So he will be a very good bowler because he is accurate and precise. Another interesting thing is that I have to select another bowler. I find that he is not accurate, but he is precise. He is not accurate, but precise. So I think, okay, this is another man because he can reproduce his balls in a target. So then he must be doing some error, which I can shift. So that if I shift it, this is a type of error. It looks to be a very systematic error. That yes, I can train him, I can coach him so that he starts putting all the balls here. So that would be my second possibility. Therefore, I hope the concept of accuracy and precision very clear to you. That accuracy means how close we are to the true value, and precision means that how much of our values are reproducible. We want that our measurement should be accurate as well as precise because exact measurements are not possible. There is always some uncertainty in the measurements. Now, when I am reporting any number, when I am making any measurement, I have some digits. Supposing I write that this measurement is 2.545 centimeter or something. What I have these digits. These digits are meaningful digits. How many are these? 1, 2, 3, 4. But one of the last one I am saying is uncertain. This is uncertain. So to solve the problem of uncertainty, we define significant figures. Significant figures. As said. Mathematically, I am saying that significant figures is nothing but these are meaningful digits in any measurement, and it also include an uncertain digit. In this case, I have 4 significant figures of my measurement. 1, 2, 3, 4. Always remember, we want the equipment, we want the measuring device such that it has a higher level of precision. We want the higher the precision, there will be more significant figures in that, in my measurement. 2.3, supposing I measure 2.3 grams, then I measure 2.323 grams. Which is more precise? This has got 4 significant figures, and this has got 2 significant figures, and I say that this measurement is better than this because it is measuring up to 4 significant figures. This is measuring up to 2 significant figures. This is more precise. When we are interested in higher precision in our measurements, certain rules have been given to identify significant figures. Let me tell you what are the rules which we will use for finding for significant figures in any measurement. What are the rules which we will use? According to the first rule, all non-zero digits are significant. If I write a number 3, 4, 5, it has all non-zero, so it has 3 significant figures. If I write 5, 7, 9, 5, 6, 1, 2, 3, 4, 5, it has 5 significant figures. Rule 2, this is my rule 1. Zeros between non-zero digits are significant. That means if I write 3, 0, 3, 1, this 0 is between 2 non-zeros, therefore there are 3 significant figures. If I write 4, 5, 0, 0, 0, 8, these zeros are between non-zero digits 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6 significant figures. I am coming to rule 3. It says that preceding zeros or zeros before non-zero digit or zeros before non-zero digits are not significant. If I write a number like 0.0025, this is not significant, this is not significant, this is not significant, only 2. It has only 2 significant figures. If I write 0.000081, this is not significant, this is not significant, this is not significant, this is not, it has only 2 significant figures. These are the rules. This is rule 3. Rule 4. Fourth, if the preceding zeros are not significant, what happens to the trailing zeros? We are saying zeros to right of a number or trailing zeros are not significant. If I write 300, this 0 is not significant, this is only one significant figure because 300. Similarly, if you write 4, 5, 8, 0, I can say that this is not significant. 1, 2, 3. These are 3 significant figures. You can see that this number actually is nothing. If I will express in exponential form, it will come 3 into, I can write 3 into 10 power 2. So I am saying this is significant in this matter. There is one difficulty with this which I will explain, and I come to the scientific notation. Fifth, I am saying that if there is a decimal, if there is a decimal, then the zeros to the right after decimal becomes significant. What I am trying to say that if I write 3.00, now what has happened? I have put a decimal here. There is a decimal here. So this makes these zeros significant. Then it has three significant figures. Anything after decimal becomes significant. And if there is no decimal, then I am saying it is not significant. If I write 500, it has two significant figures, and if I write 5.0000, then all these become significant. 1, 2, 3, 4, 5. This has 5 significant figures. If I have a number, if I am measuring exact things, supposing in a class I have 10 students, there is no uncertainty in such a measurement because students have to be 10. Students cannot be 10.1 or 10.2 or 10.3. This is an exact number. So when I have an exact number means number of objects. Supposing I say the number of objects are 75. This is exact number. 75 students. This is exact number. This has got infinite significant figures, we can say, because I can express this number as 7.0000 and so on. So such numbers we can say that, assume that okay, this is an exact value and it has infinite significant figures. Therefore, in our measurements we will be using significant figures which are nothing but meaningful digits and which also include the uncertain digit. And you will see that the more the number of significant digits, then more accurate is my measurement, more precise is my measurement. If I want better precision, higher precision, then my significant figure should be more. As the significant figure increases, precision increases, precision will become more. We can apply this. Let us see another important thing, scientific notation. What is the meaning of scientific notation? If I have a number like 5300000, now I can see there are large number of zeros, or in chemistry we are dealing with numbers like Avogadro's number, which is having 10 power 23 zeros. So instead of expressing them like this, if I have a number like 010053, we can express this number in scientific notation. I say that this number can be expressed in this form, n into 10 power n. Scientific notation. The number can be expressed in this form. This is a number between 1 to 10, and this is an integer. This is an integer which can have minus or plus value. For example, if I have to write this number in scientific notation, then it will become 5.3, because this number has to be between 1 and 2. 1, 2, 3, 4, 5, 6. So I am going from right to left. Therefore, this is 10 power 1, 2, 3, 4, 5, 6, 10 power 6. This is a scientific representation of this number. If I have to represent this number, I say 5.3. I have to go 1, 2, 3 from left to right. So I can write 10 minus 3. So it will be convenient for us to express our number in scientific notation. It will make our calculations more easy, and also it will be easy to handle the 10 to the power numbers in our calculations. Therefore, we can do this. Another thing which we very commonly will be using will be rounding off. Rounding off. That we said that we are representing numbers in terms of significant figures. Supposing I have a number 35.1567. But sometimes it may not be useful to represent numbers in 1, 2, 3, 4, 5, 6, 7 significant figures. I want the number to be only in 4 significant figures. So what I do, 1, 2, 3, 4. This number we want to round off. round off. So there are certain rules for rounding off this number. If I want to represent this number in 4 significant figures, I will check the number next to it. If it is more than 5, I will increase this number by 1. Here it is 6, therefore it becomes 35.16. This has 4 SF, significant figures. This is rounding off process. Supposing this number was 35.1547. This number I want to round in 4 significant figures. Here you can see that this number is less than 5. Therefore, the answer of this will be 35.15. I will not increase the number, it will remain the same. This has got 4 significant figures. Supposing this number was 5. Supposing this number is 35.1557. I want to round this number to 4 significant figures. Then I will see that this is now not greater than 5, neither less than 5. If this number is odd, I will increase this number by 1. So the answer is 35.16. If this number was even, the number will remain the same. So this is what we call as a rounding off. This we will be using while doing our calculations. We are trying to get minimum uncertainty, minimum error. We are trying to be as accurate and as precise as possible in our measurements. At the same time, we are trying to get numbers which are significant numbers and trying to use scientific notation and round off as much as possible. Further, I will see that if I have to do some additions, subtractions, multiplications and divisions, we will be using certain rules